Hi guys, welcome back to our channel Unknown IITians. Today we are going to discuss about quadratic equations. Today we are going to cover what is a quadratic function, slope of the quadratic function, what is a quadratic equation, intercept form, standard form, and conversion of intercept to standard and standard to intercept form of a quadratic equations, and how to solve quadratic equation by completing the square method and solving the irrational roots of quadratic equation and the quadratic formula. Okay, so now let's get started. Firstly, what is a quadratic function? So quadratic function, it is a basic equation which is written in the form of y is equal to ax square plus bx plus c. So the highest degree of this quadratic function is 2. As we have discussed in the previous chapters, degree of an equation is the highest power in that whole equation. So here the highest power of x is 2, so the degree of equation is 2. So ax square is the quadratic term, bx is the linear term as the x power is 1, and c is a constant. Okay, next, the graph of a parabola. The graph of a quadratic equation, it is a parabola. So how does a parabola look like? So this is the graph of a quadratic equation. It might be in some other shape also. It might be inverted and it might touch x-axis at 2 points. So this is the just basic diagram of a quadratic equations graph. So C is considered as the y-intercept of the quadratic function. Okay, so now here given, see, if this is the graph of your given quadratic equation, this point, the lowest point will be the minimum value, for that quadratic function. Okay, the graph will be upward parabola if a is greater than 0. Okay, for a quadratic equation, the graph to be an upward parabola, the coefficient of the quadratic term must be greater than 0. If the quadratic term's coefficient is less than 0, then the graph will be a downward parabola. That means this point, the highest point, this is called the vertex of the parabola, will be the maximum. Okay. Next, slope of a quadratic function. So for a function y is equal to ax square plus bx plus c, the slope m is delta y by delta x. That means differentiation of y with respect to x. Okay, that means dy by dx is equal to d by dx into ax square plus bx plus c, that is 2ax plus b. So this is the slope of a quadratic equation. So to find slope of a quadratic equation at particular point, it's not quadratic equation, it's quadratic function. To find the slope at a given point for a quadratic function, you have to substitute that point in the slope equation. Here m is equal to 2ax plus b. For suppose we are given a point 2, 2. Okay, then the slope will be 2a into 2 plus b. Okay, to find the slope at given point, you have to substitute the x value in the slope equation. Next, quadratic equations. What are quadratic equations. Before, we have discussed what are quadratic functions. Quadratic function is a function written in the form of ax square plus bx plus c. So now if that ax square plus bx plus c is equal to some value, that means for suppose plus c is equal to some d, then this is considered to be a quadratic equation. So here the definition is given. A quadratic equation is a quadratic expression that is equal to something. So here this quadratic expression is equal to something d. So this is a quadratic equation. The quadratic equation contains terms up to x square. As we have discussed before, x square is the highest power for a quadratic equation. So here we are given a simple examples. X square is equal to 5. Here the quadratic expression is equal to 5. So this is a quadratic equation. Similarly, the remaining examples. So here, to solve the quadratic equation, for suppose we were given an equation like this, just consider this x square is equal to 5. So now to solve this equation, solving this equation means finding the x values which satisfy this equation. So to find those x values, we have to set it to 0. That means we have to set this quadratic equation to 0. How can we set it? So now if we subtract minus 5 from both the sides, x square minus 5 is equal to 5 minus 5. That implies x square minus 5 is equal to 0. So now by subtracting 5 from both the sides, we set this quadratic equation to 0. So now we can solve the equation. Okay, this is the way we solve a quadratic equation. We have to set the equation to 0. So for a quadratic equation, there can be one real root, two real roots, or no real roots. Here real roots means the number of real roots means the solutions. So x values, there can be 0 real roots, 0 real solutions, 1 real solution, 2 real solutions. Okay. Next, quadratic functions in intercept form. Okay. For suppose we were given an equation y is equal to 2 into x plus 3 into x minus 1. So this is the intercept form of a quadratic equation. So how do we know that this is a quadratic, it's not a quadratic equation, it's a quadratic function. How do we know that this is a quadratic function or not? So now let's check what this equation will be. Multiplying these two, x square minus x plus 3x minus 3. That means x square plus 2x minus 3. So here we got this equation in the previous form. So this is the general form, whereas this is the intercept form of a quadratic equation. Okay, so that means for suppose the graph of a quadratic function be this, then it touching x-axis at some point P and some point Q. So here P and Q, the points where the graph touching the x-axis will be the x-intercepts. Okay, so now this function, this y is equal to 2 into x plus 3 into x minus 1. So now let us set this to 0. what is the function we have? Y is equal to, just a minute, 2 into x plus 3 into x minus 1. Two into x plus 3 into x minus 1. Okay, now let's draw the graph. So when this equation will be 0, so for this equation to touch x-axis, that equation will become 0 at that particular x value. That means if for an x value the equation becomes 0, that means the graph of that function will touch x-axis at that point. So now we have to find at which points the function will be equal to 0. Here if we substitute x is equal to 1, this will be 2 into, let's change the color, 1 plus 3 into 1 minus 1. So this will be equal to 0. That means 1 is the point. 1 is one of the point where the graph will touch the x-axis. And for suppose if we substitute x is equal to minus 3, that will be 2 into minus 3 plus 3 into 3 minus 3 minus 1. This is also becoming 0, as this will be 0. Here 1 minus 1 will be 0. That means minus 3 is also one of the point. So now the graph will look like this, something like this. I just drawn a rough graph. This is not the accurate and exact one. So this will be something, a parabola which touches the x-axis at minus 3 and 1. So now the intercepts of this particular quadratic function are minus 3 and 1. So this is the way we draw the graph, and this is the way we find the intercepts of a quadratic function. The intercepts will help us in drawing the graph. Okay. So now let's discuss how to convert intercept form of a quadratic function to standard form. So we were given a quadratic function in its intercept form, 2x plus 3 into 5x minus 8. Okay, what is the standard form of a quadratic function? It is y is equal to ax square plus bx plus c. So basically this is the standard form and this is the intercept form. So to convert this intercept form to standard form, we follow FOIL method. Okay, we follow the FOIL method. What is the FOIL method? So these 2x and 5x are the first terms. So first term in this equation is 2x and in this equation is 5x. So 2x plus 3 into 5x minus 8. Okay, so now 2x and 5x are the first terms. So now we will multiply these two. Okay, the first, whereas 3 and 8 are the last terms. So the last. Okay, and 3 and 5x, these are the inner ones, whereas 2x and 8 are the outer ones. So we will follow this FOIL FOIL method. FOIL. Okay. So now let's see in this clearly. What is the first term? We multiplied 2x and 5x. That means it is 10x square. Next, the outer one. What are the outer ones? 2x and minus 8. So 2x into minus 8, that is minus 16x. Next, the inner ones. 3 into 5x, that is 15x. And the last ones. The last ones are 3 into minus 8, that is minus 24. So now by adding all these, we will get 10x square minus 16x plus 15x minus 24. Simplifying this will give you 10x square minus x minus 24. So this is the method that we use to convert the intercept form of a quadratic function to its standard form. So it's really important. Remember, it's the FOIL method. Okay. So now we were given 3x minus 4 and 5x plus 1. So now we will use this FOIL method to convert this intercept form into its standard form. So now what we have to multiply? First ones, the last, inner and the outer. Okay, firstly, the first multiplication will give you 3x into 5x, that is 15x. Next, the outer one will give you 3x into 1, that is 3x. Sorry, this is 15x square. Next, inner. Minus 4 into 5x, that is minus 20. The last one is minus 4 into 1, that is minus 4. Okay. Now by adding all this, we will get 15x square plus 3x. So here we are having x minus 20x plus 4. Okay, that means 15x square minus 17x plus 4. So this is the general form of the given quadratic equation. We have converted the intercept form into the general form. Okay, we use the method FOIL: first, outer, inner, and the last. Okay, this is one of the example. Next, so now let's discuss how to convert the standard form into intercept form. So previously we have seen how to convert the standard form into its intercept form into its standard form. So now suppose we were given a standard form like this, then how to convert this into the intercept one. So here also one of the method is we use the FOIL method, but in the reverse way. So let's see how to do. So now we were given 5x square minus 13x plus 6. So how the intercept form of a function be? it will be ax plus b into cx plus d, right? So now applying FOIL method for this ax plus b into cx plus d, so it will be multiplying the first, the outer, inner, so this is, I'm sorry, first, inner, outer and the last. So that means it is ax ac x square, wait, that is ac x square plus bcx plus next ADX plus BD. Okay. On comparing, so let's simplify this more. ACX square plus AD plus BC into x square plus BD. Okay. So now comparing this equation with the original one. So here AC is equal to 5, AD plus BC is equal to minus 13 and BD is equal to 6. So here multiplying AC and BD will give you AC into BD is 30. That means it can be written as minus 10 into minus 3. So on comparing this two, here, okay, so sorry, this AC and BD can also be written as AD into BC, right? So this will be again the same. We are rearranging it. So now on comparing these two, AD can be minus 10 and BC can be 2. So this is one of the method to solve. So let's look the other one also. So now, sorry, the equation is 5x square minus 13x plus 6. 5x square minus 13x plus 6. So now by simplifying this, so 5x square, so this 13x can be written as minus 10x minus 3x plus 6. Okay. So now from these first two terms, if we take 5x as a common term, we can write this as x minus 2. So now let's check. 5x into x is 5x square. 5x minus 2 is minus 10x. So again from the second, these two terms, if we take 3 as a common one, minus 3 as a common one, we can write it as x minus 2. So now from, say minus 13x plus 6, 5x square minus 10x minus 3x plus 6. From these two terms, taking 5x common, we will get x minus 2. From these two terms, taking minus 3 common, we will get x minus 2. From these two terms, if we take x minus 2 common, we get 5x minus 3. That means taking 5 common from this, we'll get x5 into x minus 3 by 5 into x minus 2. So this is the intercept form of the given quadratic function. Okay. This is how we convert it. Next. So now we were given this minus 15x square plus 3x plus 12. So from this equation, let's take 3 as a common one. We will get minus 5x square plus x plus 4. Okay. Now this 5x square, this can be written as plus 5x minus 4x plus 4. So here we wrote x as 5x minus 4x. Okay. Now from these two terms, if we take 5x as a common term, or else let's take minus 5x, we will get x minus 1. From these two terms, if we take minus 4, we will get x minus 1. Again, from these two terms, if we take x minus 1 as common, we get x minus 1 into minus 5x minus 4 into 3. Okay, that means minus 3 into x minus 1 into x minus 1 into 5x plus 4. Here we took minus common and multiplied with 3. So minus 3 into x minus 1 into 5x plus 4. This is the intercept form of the given equation. Okay. Next, solving a quadratic equation by completing square method. So now we have a method called completing square method to solve a quadratic equation. For suppose, let's discuss here. We have two different methods. Let's discuss both of them in detail. First old method, x square plus 10x x square plus 10x minus 24 is equal to 0. So as we have discussed in before methods, a, b, c, d will be minus 24, whereas ad plus bc will be plus 10. And we will write it as x square plus 10x minus 24 will be equal to x square plus 12x minus 2x minus 24. Okay. On solving this, we get the intercept form, and from that, equating that intercept form to 0, we will get the real roots of the equation. So this is the old method, the method we have discussed previously. So now what is the new method? New method is, so for suppose we were given an equation, x square plus 10x is equal to 24. So now this can be written as x square plus 10x minus 24 is equal to 0. That means we are subtracting 24 from both the sides. So now here this can be written as x square plus 10x, okay, plus 25 minus 24 is equal to 25. That means we are adding 25 on both sides. So let me write the steps. Here subtracting 24 on both sides, and here adding 25 on both sides. Okay, that will give you this one. So here this is in the form of x minus 5 whole square. So recall the squaring, so like x minus a whole square form, how that form will look like. Sorry, it's not x minus, it's x plus. So how the form x plus a whole square will look like? It will be x square plus a square plus 2ax. Here x square, and here we are having 25. 5 square is 25, that means a square is there, and 2ax, 2 into 5 into x, that is 10x. So this is in the form of x square plus x plus 5 whole square minus 24 is equal to 25. That means x plus 5 whole square is equal to 49. That means we are adding 24 on the both sides. Here add 24 on both sides. We are getting this equation. Okay, so now x plus 5 whole square is equal to 49. That means x plus 5 can be plus 7 or minus 7. So from that we can get both the x values. X plus 5 is equal to 7. That means x is equal to 2, and x plus 5 is equal to minus 7. That means x is equal to minus 12. So this is the square completing method. That means from the given terms of a quadratic equation, we try to make it as the equation as a perfect square one, and we will add the remaining terms. Okay, so here we added 25 to make it a perfect square, and we were left with minus 24. That means we will take it to the right hand side, and finally we'll get the equation in terms of a perfect square. So that will give us a quick answer compared to this one. Okay, so for example, let's see another example to make it more clear. So now we were given x square plus 4x minus 12 is equal to 0. Okay, so now here look, this is x square 4x. That means this might be 2 into 2x. That means a might be 2. That means here we try to convert it into x minus 2 whole square form. So this is how we get the idea. So, okay, remember this is in the form 2 into 2x. So a might be 2. So here x minus 2 whole square is this is x plus 2 whole square, not minus 2. So how this form will actually look like: x square plus 4 plus 2 into 2x. That means x square plus 4x plus 4. See here we are having the x plus 4x term. Okay, here we are having the x square plus 4x term in both sides. What the term missing is plus 4. So now adding 4 on both sides, that will give you x square plus 4x minus 8 is plus 4 is equal to adding 12 on both sides will give you 12 plus 4, that is 16. So x plus 2 whole square is equal to 16. That implies, let me erase something here. x square plus 4x plus 4 is equal to 12 plus 4, that is 16. That means x plus 2 whole square is equal to 16. That implies x plus 2 is plus or minus 4. So x plus 2 can be equal to 4, x plus 2 can be minus 4. That means x is 2 or x is 2, so minus 6. So the real solutions of this equation are 2 and minus 6. So now here we got 2 and minus 6. So how to check whether these are the correct solutions or not? Simply we have to substitute these values in the given equation. So if the values satisfy the equation, that means we got the correct values. See here, substituting 2 in this equation, 2 square is 4 plus 4 into 2 is 8. 4 plus 8 minus 12, that means 12 minus 12 is equal to 0. Similarly for minus 6, minus 6 whole square is 36 plus 4 into minus 6, that means minus 24. That means 36 minus 24 minus 12. That also will be equal to 0. So in this way we have to check whether the obtained solutions are correct or not. Okay, this is one of the method to check. So now let's solve this question to get more clarity on the method. Okay. So now we were given x square plus 6x plus 4 is equal to 0. So how this is looking like? X square plus 2 into 3x plus 4. That means here a can be 3. That means this is in the form of x square plus 3 whole square. So that is x square plus 6x plus 9. So here we are having x square plus 6x, x square plus 6x, but 9 is missing. So now adding 9 on both sides will give you x square plus 6x plus 4 plus 9 is equal to, why to add 9? Simply if you add 5, what will happen? So let's see. Okay. So now here we are having 4. Okay. Now if we add 5, we will get like this. So that means x square plus 6x plus 9 is equal to 5. So we already got this equation in this form. So that means x plus 3 whole square is equal to 5. That means x plus 3 will be equal to plus or minus root 5. That means x will be minus 3 plus or minus root 5. So these two are the roots for this equation. One is minus root 3, minus root 5 minus 3, and one is root 5 minus 3. Okay. Next. So till now we have seen the cases in which the quadratic equations are having rational roots. In previous case we got irrational roots. So irrational means it is including root 5, right? So that is an irrational root. So in such cases, if we were having an irrational root, then we have a quadratic formula to find the roots of such quadratic equations. That means the quadratic equations with irrational roots. So the formula is minus b plus or minus root over b square minus 4ac by 2a. So what are these a, b and c? These are the coefficients of the quadratic equation. So we have discussed before, what is the general form? A, that is ax square plus bx plus c, right? So here a means the coefficient of the x square term, b the coefficient of x term, c is the coefficient of, it's not coefficient, it's the constant term. The formula is minus b, just a second, minus b plus or minus b square root over plus or minus root over b square minus 4ac by 2a. That means minus b plus root over b square minus 4ac by 2a is one root, and minus b minus root over b square minus 4ac by 2a is the other root. So here check the sign properly. Here one is minus and the other one, here this is plus and the other one is minus. So this is the formula to find the irrational roots of a quadratic equation. Okay, let's see this example. So we have to solve this for the irrational equation. So the general term is ax square plus bx plus c, right? Now comparing these two equations, we get a is minus 2, b is minus 4, c is 3. Okay, so the formula we discussed is minus b plus or minus root over b square minus 4ac by 2a. Okay, so now substituting these values in this formula. Here b is minus 4 plus or minus root over minus 4 whole square minus 4 into a is minus 2, c is 3 by 2 into a is minus 2. That means 4 plus or minus root over 16 minus 4 into, so here we are having minus and here also we are having minus. That means minus into minus will become plus. So let me write it more clearly to understand, for better understanding. This is minus 4 into minus 2 into 3. So here we are having a minus, here also we are having a minus. So minus into minus will become plus. So here we'll get plus 4 into 2 is 8, 8 into 2 is 8 into 3 is 24 by minus 4. So that means minus 4 plus or minus 40 by minus 4. So these two are the irrational roots of this equation. We can simplify this further. That means here if we take wait, let me write it somewhat small that way. Wait, that will be minus 4 plus or minus root 40 by minus 4, right? So now this can be written as 4 into 10 by 4 minus 4, right? So now root over minus 4 is 2. That means minus 4 plus or minus 2 into root 10 by 4 by minus 4. That means we can cancel. This will be 2, this will be 2 and this will be 1. So finally we can write it as, here I am not having place, I'll write it here above, minus 2 plus or minus root 10 by minus 2. Okay, these two are the irrational roots of the given quadratic equation. Okay, next, the quadratic formula. So here we discuss the quadratic formula x equal to minus b plus or minus root over b square minus 4ac by 2a. This is really a very important formula. So now let's discuss about the discriminant. What is discriminant? This term b square minus 4ac is the discriminant of the quadratic equation. B square minus 4ac. So what can we what the conclusions that we can derive from this discriminant value? So for example, if b square, let me write it clearly, b square minus 4ac is equal to 0. That means the two roots of the equation are real and equal. Okay, and for suppose if b square minus 4ac is less than 0, b square minus 4ac is less than 0, the roots are not real. If that is greater than 0, the roots are real, rational, and not equal. If this is greater than 0 and a perfect square. If it is not a perfect square, then the roots are irrational. Okay. So these are the conclusions that we can derive from the discriminant value. If it is equal to 0, the roots are real and equal. If this is less than 0, the roots of the equation are not real. And if it is greater than 0 and the discriminant is a perfect square, then the roots are real, rational, and not equal. If the discriminant is greater than 0 but not a perfect square, then the roots are real, irrational, and not equal. Okay. So now let's see this. So now let's determine from the discriminant whether this equation is having real roots or non-real, rational or irrational. So let's see. Here once again we'll write the general form. So writing this general form will always give you a clear picture. So what are the coefficients are. So without any confusion we can just compare and write the coefficients. Sometimes we may make a mistake if we write directly. So for example, we may skip the minus sign. We may not see the minus sign. So if we start comparing, then it will be very easy. The chance of making mistake will be less. Okay. So a is equal to 3, b is minus 2, and c is minus 5. Okay, so now the discriminant is b square minus 4ac. That is minus 2 whole square minus 4 into 3 into minus 5. That is 4 minus 4 into 3 is 12, 12 into 5 is 60, plus 60, that is 64. This is a perfect square, right? That means this equation is having real, rational, and unequal roots. Real, rational, I'll write it more clearly. Real, rational, and unequal roots. So we got the discriminant as a perfect square. So as we have discussed before, the roots are real, rational, and unequal. Okay. So now so far we discussed in this lecture what is a quadratic expression, and what is a quadratic equation, what is an intercept form, the general form, and how to convert the FOIL method, how to convert intercept to general and general to intercept, and the formula for calculating the roots and the discriminant. So these are the major parts of the quadratic equations. Okay, so that's all for this lecture. Thank you so much.